Hello, Math 30. This is a continuation of our Trig Functions unit, and you, in Lesson 6, learned how to graph sine and cosine and tangent, their basic functions. And now we're going to take what we learned in transformations, and we're going to look at the things we looked at when we transformed other graphs. And now we're just going to do it to the basic sine graph and the basic cosine graph, and you need to know those critical points for those graphs that we've talked about. So in this lesson, we look at example 1, and we look how sine x and cosine x are transformed. So when we look at what value has been added to that and how that transformed the graph, we can see that that a value is on the outside, so that clearly, from what we learned in transformation, applies a vertical stretch by a factor of 2. We see that there's a 2 on the inside. That refers to our b value. Now b value is 2, therefore that implies a horizontal stretch by a factor of 1/2, and that's about the y-axis. We look at -3, that's clearly an a value, that is a equal to -3, therefore that is a vertical stretch by a factor of, in this case, 3, and a reflection in the x-axis. And lastly, we look at the -3, and the -3 is clearly a b value, that's b equal to -3, so therefore that is my horizontal stretch by a factor of, in this case, 1/3, and a reflection in this case, the y-axis. It is a horizontal reflection. The next question asks which had a change in amplitude and which had a change in period. 1 and 3 had a change in amplitude because those were the ones that were vertically stretched. And clearly period is a horizontal condition, and therefore the horizontal stretches were 2 and 4. Complete the following table, and you should not need to use your calculator. That should be something that you can do. So complete the following table and see where you end up. So if we consider how A and B affect our amplitude and period, which is what this lesson is all about, clearly 2 stretches by 2, so that that is 2. If I just continue down here and just stick with amplitude in my head, then this is a, in this case, this is, there is no vertical stretch, so that's a 1. This has a vertical stretch of 3, that's a 1. There is no this is 5, and this clearly is 1/3, and this would be A. If I move over to the period, how has period been stretched? Well, I can clearly see that there is no b value, so the period in the second one is just going to be 2 pi. This is going to be 1/2 of 2 pi, so that would be equal to pi. This is simply 2 pi. There is no stretch. This would be 1/3 of 2 pi, so that makes this 2 pi over 3. This is 1/4 of 2 pi, so therefore that is going to be pi over 2. This is 2 over 1 times 2 pi, so that's going to be 4 pi. And lastly, what do we do with the b value? We horizontally stretch by a factor of 1 over b, so therefore it would be 1 over b times 2 pi, so the period with the b value will always be 2 pi over b. Describe the effects of primary rate. Well, clearly we kind of talked about that already. It's what we did in transformations. It's a vertical stretch by a factor of a. And what happens with b? It is a horizontal stretch by a factor of, in this case, 1 over b. We always take the reciprocal. Would you expect the same things for cosine? You would expect the same things for any function because that's what they do. When you put a value on the outside of a function, it vertically stretches it. When you put a value on the inside of a function, it horizontally stretches it, and again, it's by the reciprocal. And on the next page, we basically have conditions. The only thing I'd like you to mention here is I really want us to see this period change as something where it's 360 degrees times 1 over b, or 2 pi times the reciprocal of the b value. Whatever the b value is, you take the reciprocal. And don't forget, tangent is only got a period of 180 degrees, so it's 180 degrees times 1 over b, or pi times 1 over b. Okay? We're going to graph some manually in a little bit. I've got a worksheet for you. I want you to continue on with the examples here and see where we're at. So to state the amplitude in the period, clearly I can see that the amplitude is going to be 4. And I can see the period, well, I find the period by going with my 2 pi and horizontally stretching by 1/2, so that makes the period pi. I sketched this graphically on the grid. Remember we talked about S, R, and T. And here's where it's really important for you to be able to graph these with your basic graph first. So I know that cosine is what I'm graphing, that if I was to start by just graphing the critical points of cosine, cosine starts at 1 at 90 degrees. Now I look at the scale. Every point here is 30, 60, 30, 60, 90, 120, 150, 180. So each of those is 30 degrees. So I look and see what would cosine normally graphed at 90 degrees. It's at 0. At 180, it's down to -1. At 270, it's at 0. And at 2 pi, it's back here. So this, whoopsie, let's do that better. This would be my graph of normal cosine. And now let's go through its transformations. Well, what if I horizontally stretched it by, what if I horizontally stretched each of the points by a factor of 4? What's my amplitude of 4? Now, my graph would be up at transformed. That would be at 4. This would be at 0. This would be at -4, 0, and 4. So this graph is now y equals 4 cosine x. But I also have to graph a horizontal stretch by a factor of 1/2. So now when I do that, this point here, each of the points is horizontally stretched. That point stays, but this point, it was at 3 units, it's now there. This point was here, it's stretched by 1/2, so that's going to be at 3. This point here was at 9, so it's now at 1, 2, 3, 4.5. And lastly, this point out here was at 12, it's now going to be at 6, and so it's right there. So my final graph is 4 times as tall and 1/2 as wide as it used to be. It has been horizontally stretched by 1/2 and vertically stretched by 4. Okay, when you continue on, a sine function having amplitude 2/3 and a period of pi over 6. Well, when we look at what we're really dealing with, y equals a times, in this case, it's a sine function, so y equals a sine bx. So you really kind of have to be careful. A is always a little easier. Because the amplitude is 2/3, therefore a is equal to 2/3. But period is equal to 2 pi times 1 over b. So when you substitute in what we've got for period, I know the period is pi over 6. So what had happened to 2 pi in order for that to happen? Well, you can look at this as a little equation. So this is, this is really pi over 6 equal to 2 pi over b. So pi times b is equal to 12 pi. So that means b must be equal to 12 pi divided by pi. So in other words, the b value must be 12. So b equals 12. Therefore, for question A, y is equal to 2/3 times sine of 12x. And that makes sense because when you think of if there's a 12 there, you must have, go back and think backwards. If there's a 12 for the b value, then that means that you must be multiplying or horizontally stretching the period of 2 pi by 1 over 12, and that will get you that pi over 6. So when you think about it, what does that mean? Therefore, 2 pi times 1 over 12, and what does that equal? Pi over 6. And that's what they said. So therefore, our b value must be correct. A cosine value that has an amplitude of 3. Well, again, that's the nice one. A equals 3. If the period is equal to 720 degrees, there's a couple ways you can think of it. You can go back, and I think if I'll just ride the same horse, period, the formula that we talked about, period is equal to 2 pi. Period is equal to 2 pi over b. So again, you substitute in there, 720 degrees is equal to 2 pi over b. Sorry, if we're dealing with degrees, 360 degrees over b. Therefore, what is b equal to? B is equal to 1/2. Therefore, my equation for this one is y equals 3 for the amplitude cosine cosine 1/2 x. And lastly, the tangent function. For the tangent to have a period of 1/2, that means that we have normally got a period equal to pi, but if it's horizontally stretched, it's horizontally stretched by 1 over b. Again, plug in into this formula, plug in, my period is pi. What happened to, my period is pi over 2, and what happened to pi what happened to our normal period of pi? What was it stretched by? So we cross multiply. 2 pi is equal to b pi, so that means b must be equal to 2. Therefore, my equation is y equals tangent 2x. And that means that the period was horizontally stretched by 1/2. And now you have graphs, state the amplitude and the period of this graph. Here's where you really need to know your critical points. This is speaking about, in this case, sine. So when I look at my graph that you have in your paper, where's my critical starting point for sine? Normally sine starts right there. When I look at where this one ends, or what's the period of this graph, you can clearly see that this graph ends right here. So how much is that period? That period is equal to pi. When I look at the amplitude and I see how high the peaks are at 3 and at -3. So what is the amplitude? The amplitude is equal to 3. What's the period? The period is equal to pi. Determine the equation of the sine function, which represents its graph. Well, I need to find the a and b value. A is equal to clearly 3, but for the period, we should have, this is another way of doing it. We should have a period of 2 pi. We don't. What happened to it? Well, it got obviously cut in half. So it was multiplied by 1/2. Therefore, mentally, the b value must be 2. All right, and therefore my equation, y is equal to 3 sine of 2x. All right. The graph represents the tides over mean seafloor. I want you to give this a go. This is leading into what we're going to be talking about next day, but using the same ideas, we can clearly see this has a little bit different. It's not talking about degrees on the axis. So I want you to give this a try and then come back and see what the answer is. So although this one's kind of different, you'll notice that clearly the amplitude, when you look and we consider cosine, the amplitude is clearly 4. And you can clearly see that the period of this graph, if you look at the horizontal distance it takes to complete that cycle, this distance is 12. So using that same formula to find b, period, is always equal to 2 pi times 1 over b. What is the stretch factor for things to be done in 12 hours? Plug in what you know. In this case, you know that the period is actually 2 pi. You know the period is 12, and 2 pi over b, we cross multiply, we get 12b is equal to 2 pi, b equals pi over 6. Therefore, that makes the equation equal to 4 times cosine pi over 6 times, I forgot to put the variable time. And that is that. Please continue with the assignment that you have been asked to do.